All right, so this lesson is a short video on a method of factoring in a particular situation called the difference of squares. So sometimes people will call this difference of squares factoring. So we're going to start off by saying that we're going to recall a bit of a binomial expansion thing here. So you'll recall from our lesson on special products that when we're expanding an expression that looks like this, we would do FOIL, so we get x squared plus 3x minus 3x minus 9. And what actually happens with those two terms in the middle, because one's a positive and one's a negative, and they're exactly the same, they wind up canceling each other off and leaving us with this expression that's right here. We call that a difference of squares because the first term and the second term are perfect squares. They're square rootable, and they're a difference of squares because we're subtracting them. All right. So again, a good example over here, a little bit further down, of 4x plus 9 multiplied by 4x minus 9. 4x times 4x is 16x squared. 4x times negative 9 is minus 36x. 9 times 4x is plus 36x. And positive 9 times negative 9 is minus 81. These two are identical. They cancel each other out. And we wind up with the 16x squared minus 81. This is, again, also a difference of squares because 16x squared is square rootable and 81 is square rootable, and the sign in the middle is subtraction. So it's a difference of squares. So now that we've set up a bit of that terminology, what is a difference of squares, we can actually probably come up with a method of factoring these differences of squares. So if we started off with this expression x squared minus 9, we could sort of say, well, it's kind of like a trinomial. I mean, it's a trinomial in disguise. The middle term was actually 0x, right? So we think about it, this is actually this, right? So we're looking for two numbers that multiply to negative 9 and add to 0. Well, if they multiply to negative 9 and they add to 0, then if they add to 0, they both have to be the same, right? They canceled each other off. And if they're both the same and they multiply to 9, the square root of 9 is actually going to reveal that number. Okay? So in real simple terms, you're going to set up your brackets just like it was a FOIL question, and you're going to take the square root of the first term. Square root of the first term, well, the square root of x squared is just x. There are your first terms. You're going to take the square root of the second term, which is 9, and that's going to get you a 3 here and a 3 here. Then you're going to basically say, well, one of them had to be plus and one of them had to be minus because they cancel each other off. So one of them had to be plus and one of them had to be minus. And there you go. It's basically just how you factor difference of squares. And the same thing goes with our 16x squared minus 81. If we wanted to go in reverse, we know that it was the result of a FOIL question that had a square root of the first term. So the square root of the first term. Square root of 16 is 4, and the square root of x squared is x. So my first term is going to be 4x. My second term is going to be the square root of that second thing. So the square root of 81 is 9. And that middle term disappeared, so one of these is a plus and one of them is a minus because it would have canceled itself out. So again, since there's no middle term, the sum number that we're looking for is 0, and the product is the constant, that number that's tagging along at the end. The numbers must be the same with opposite signs. So be careful here because it's not plus 9 and plus 9. It's a plus 9 and then a minus 9 because they cancel each other off. So again, I went through that process while I was doing those two examples. Note that to factor a difference of squares, you're simply going to take the square root of each of the two terms and then to determine what goes in the brackets, and then you're going to add one of them and subtract the other. It's going to happen in a second. I'd like you to pause the video and just do A and B, okay? The solutions to A and B will pop up. If you want to, you could try A, B, C, D, and E all at the same time, but just try A and B. Okay, so the answers for A and B, pretty simple stuff. The square root of this first term gives us the first term there. The square root of the second term gives us that second term there. And because it was a difference of squares, right, there was a minus sign in the middle, we put a plus and a minus inside of our double brackets. If we wanted to check this answer again, we could do FOIL. So I might as well do that the very first one. X times x, so first, would give us x squared. Outside, x times negative 7, negative 7. Inside, positive 7 times x, and positive 7 times negative 7 is negative 49. If I'm collecting like terms, those two like terms cancel each other off and leave me with x squared minus 49. Again, just a reminder that the stuff that I've written in red there is not part of the solution. It's just part of checking. Okay, so Make that clear. When I'm asking you to factor, I'm asking you to just leave it as blue, that answer there. So nothing much more complicated with question B, except we have this y squared tagging along. It's still a perfect square because you could square root y squared as well. So your first term is going to be 5x because the square root of 25x squared was the 5x. Your second term is going to be 8y because that's the square root of 64y squared. Because, again, this is a difference of squares, there's a minus right in the middle there, you're going to have a plus sign and a minus sign inside of your set of brackets. And trust me, if you'd like to pause, you can go ahead and do FOIL of my answer in blue there, but it is actually equal to what's above. Now, I want you to consider questions C, D, and E. You're going to pause the video in just a second, but let me give you a few hints. Okay, with questions C, I would suggest that 2 is not a perfect square, and neither is 72. You can't take the square root of 72, and you can't take the square root of 2. So try and think about what you could do first with those two examples. With question D, it looks a little bit different than the ones we've been seeing, but 16 is a perfect square, and so is x to the power of 4. There's a little bit of a trick, though, with question D as well. With question E, oh my goodness, there are fractions. But you'll notice there's something special about all the numbers bouncing around there. They, too, are all perfect squares. So that should also obey some of our rules about difference of squares factoring. So go ahead, pause the video, consider those three examples, and the answers will pop up in just a sec. Okay, so for question C, here's the solution. Hopefully my hint about common factoring or what you must do first is there. If you common factor the 2 out, you'll notice that the stuff in the brackets magically becomes a perfect difference of squares because x squared is square rootable and so is 36, okay? So really, again, the common factoring is your very first point of call there. If you don't common factor, you can't really do much with that question. Question D is interesting and unique because with question D, you do your difference of squares factoring and you get the first line there, but that thing that I've just underlined in green, 4x squared minus 9, that too is a difference of squares, right? Because 4x squared is square rootable and 9 is square rootable, and so that guy can be difference of squared factored as well. Okay, so that's kind of interesting. It's kind of like a difference of squares inside of a difference of squares. With question E, you've got fractions, but again, really the game is exactly the same. The square root of this first term, a squared over 16, works out to be a over 4 because the square root of a squared is a, and the square root of 16 is 4. Your second term, again, the square root of 25 is 5, and the square root of 81 is 9, so 5 over 9. Really no different, just treated exactly the same as a number. All right, so that's essentially it for tonight, guys. Factoring difference of squares, super easy method of factoring. Hopefully you've got it. We'll see you tomorrow.